Welcome to part 4 of Mathematics exam series for Victoria, Australia. In this video, we will solve 2020 Trial Exam 1 paper questions from 5 to 7. Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. This is the second part of a 2020 trial exam paper for mathematics in Victoria, Australia, and this is a technology-free paper. Question 5 is a circular function, has two parts, fx equal to 2 sine x plus cosine the sum of x plus 5 pi over 6. In order to sketch the two functions within the given domain for question 5.1, we need to find out the properties of the two functions like period, amplitude, x and y intercepts, turning points, etc. If possible, list a table of data that preserving all the important features of these two circular functions and then connecting these points smoothly. These are the two graphs of the two circular functions. The function curve of y equals 2 sine x is in red, while the function curve of y equals cosine the sum of x plus 5 pi over 6 is in green color. To find the x-intercepts of this function, there are actually two approaches. The first one is the graphic approach, and the second one is the algebra approach. Based on the superposition principle, by adding the corresponding y coordinates of the two curves, we sketch the combined graph as displayed here. After sketching the combined graph, we may estimate the x-intercepts of the graph. They are around -2.5, 0.48, and 3.65. With this graphic approach, we are unable to get accurate results, since the accuracy depends on how precisely we sketch the original graphs, as well as the combined graph using superposition method. Now let's look at the algebra approach. For this approach, we first expand the circular function and then combine the likely terms to the form of 3 over 2 times sine x minus square root 3 over 2 times cosine x equals 0. Then we modify the equation by times and divided by square root 3, and then apply the addition formula to simplify it as square root 3 times sine x minus pi over 6, or in parentheses equals 0. Now we solve the circular function and work out that x equals -5 pi over 6, or pi over 6, or 7 pi over 6. As for the general solution, since we have the equation of sine x minus pi over 6, or in parentheses equals 0, the general solution for this equation is n pi plus pi over 6, where n is an arbitrary integer. Question 6 shows us a function of cotangent x. To find the derivative of the cotangent x, we may apply the derivative quotient rule, which gives the result of -1 over sine squared x, to evaluate the definite integral from pi over 4 to pi over 2 of cosine squared x over sine squared x dx. We may use 1 minus sine squared x to replace cosine squared x. In this way, the definite integral can be evaluated, and the result after simplification is 1 minus pi over 4. Question 7 is a probability question. The probability of event A and the probability of event not B intercepts with the events A are given. They are 3 over 5 and 1 over 4 respectively. Following this, 3 questions are asked. The first question is to evaluate the probability of event A intercepts event B. The second question is asking to evaluate the probability of event A union with event B, given the conditional probability of event A occurring when event B has already occurred is 3 over 5. The last question is to determine whether events not A and not B are independent to each other. For the first question, since the probability of event A is equal to the probability of event A intercepts event B plus the probability of event A intercepts event of not B, so the probability of event A intercepts event B equals 7 over 20. We draw a probability table, sometimes call it Carnot map, and fill in all the given information in the table. As for question 2, the conditional probability of event A occurring when the event B has already occurred can also be used to calculate the probability of event B, which is 7 over 12. After having the probability of event B, the probability addition rule can be used to calculate the probability of event A union with the event B, which is 5 over 6. After working out the results required in questions 1 and 2, we complete the probability table as displayed on the right of the screen. In order to determine whether event not A and event not B are independent to each other, we may either to calculate the conditional probability of event not A given event not B has already happened, or calculate the conditional probability of event not B given event not A has already happened. The calculation results show that the conditional probability of event not A given event not B has already happened equals to the probability of event not A, and vice versa. Based on the calculation results, the event not A and the event not B are independent. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.